Hello dear students, all of you welcome to Vidyan classes. Today we will discuss some important problems on multiplication of matrices. Part 1 NCERT page number 100 miscellaneous exercise on chapter 3 question number 3 if A is a matrix having elements 3 minus 4 1 minus 1 then prove that A to the n is a matrix having elements 1 plus 2n minus 4n n 1 minus 2n where n is a natural number. The statement can be proved by using the principle of mathematical induction. The statement can be proved by using the principle of mathematical induction. Let Pn be the statement. Let Pn be the statement. Pn so that A to the n is a matrix having elements 1 plus 2n minus 4n n 1 minus 2n where A is a matrix having elements 3 minus 4 1 minus 1. It is given. Step 1. N is equal to 1. Elicit of P1. For n is equal to 1, the statement is P1, elicit of P1 which is equal to A to the 1 which is equal to A. Elicit of P1 which is equal to 1 plus 2 that is equal to 3 minus 4 it is 1 1 minus 2 that is minus 1 which is equal to A. Implies elicit of P1 is equal to elicit of P1. So P1 is true. So P1 is true. The first step is proved that it is true. Step 2 for n is equal to k. Let pk for n is equal to k. The statement is pk. Let pk is true for some positive integer k. Let pk is true for some positive integer k. Pk so that A to the power k For n is equal to k, it is a to the k 1 plus 2k minus 4k. N is equal to k 1 minus 2k. For n is equal to k, a to the statement is pk, a to the k 1 plus 2k minus 4k, k 1 minus 2k. Step 3. For n is equal to k plus 1. To show p k plus 1 is true whenever pk is true. In mathematical induction, there exist 3 steps. The first step is must be proved. The second step is assumed it is true. The third step will be proved using the second step. Clear? Now p k plus 1 so that a to the power k plus 1, which is same as a to the k into a. P k plus 1, the left hand side is a to the power n is k plus 1. If the left hand side is increased to a to the k plus 1, the right hand side must be 1 plus 2 k plus 1 minus 4 k plus 1 k plus 1 1 minus 2 k plus 1, so that the statement will be true. The statement Pn is true if P1 is true, let Pk is true, Pk plus 1 is true when it is assumed that Pk is true, so that the statement is true. Which is same as a to the k is assumed that it is true, a to the pk so that a to the k, it is assumed that true. A to the k is a matrix having elements 1 plus 2k minus 4k, k 1 minus 2k. And A is given by 3 minus 4, 1 minus 1. Clear? It is the pk, it is the pk is equal to a to the k. Using the principle of matrix multiplication or by the rule of matrix multiplication, go through row 1, come down in column 1, multiply the corresponding elements and add them. 1 plus 2k into 3, that is 3 plus 6k. 1 plus 2k into 3 minus 4k into 1, that is 4k. Go through row 1, come down in each column. Multiply the corresponding elements, that means first to first, second to second. 1 plus 2k minus 4, that is minus 4 minus 8k. minus 4k into minus 1, that is equal to 4k. Clear? Next, row 2. Go through row 2, come down in column 1 and column 2. Multiply the corresponding elements and add them. K into 3, that is equal to 3k. 1 minus 2k into 1. K into minus 4, that is minus 4k. 1 minus 2k into minus 1, that is minus 1 plus 2k. Clear? 3 plus 6k minus 4k, 1 plus 2k into this, minus 4 minus 8k minus 4k. K into 3, that is equal to 3k. 1 minus 2k into 1, that is equal to 1 minus 2k. K into minus 4 minus 4k. Minus 1 into this is equal to minus 1 plus 2k. Which is same as P plus 2k minus 4 minus 4k. K plus 1 minus 2k minus 1. Clear? Minus 2k plus 1, which is same as 1 plus 2 into k plus 1. That is 2k plus 2 plus 1, that is 3 plus 2k. It can be written as minus 4k plus 1. K plus 1. And it is 1 minus 2k plus 1. Minus 2k minus 2 plus 1. This is same as this. When n is replaced by k plus 1, the right hand side is also replaced by k plus 1. So p k plus 1 is true. So p k plus 1 is true whenever pk is true. Clear? Pk plus 1 is true whenever pk is true. Therefore, Pn is true for all n belongs to capital N. In mathematical induction, we use 3 steps. The first step must be proved. In first step, we have proved it is true for n is equal to 1. In second step, we assume pk is true for some positive integer k. It is assumed that the statement is true. In third step, we will prove the statement is true. In step 3, we will show that pk plus 1 is true whenever pk is true. The left side is increased to k plus 1, that is n is equal to k plus 1. The right hand side also increased to k plus 1, that means n is replaced by k plus 1. So pk plus 1 is true whenever pk is true. Therefore pn is true for all n belongs to capital N. Capital N represent the set of natural numbers. Clear? Clear? Question number 1. Let capital A is a matrix having elements 0, 1, 0, 0 so that ai plus ba whole to the n is equal to a to the n I plus n into a to the n minus 1 ba, where I is the identity matrix of order 2 and n belongs to capital N. That means n is a natural number. Since n is a natural number, the statement can be proved by the principle of mathematical induction. For every natural number, the mathematical induction can be used. The statement can be proved by using the principle of mathematical induction. Let Pn be the statement Pn so that ai plus ba whole to the n is equal to a to the n I plus n into a to the power n minus 1 ba. It is the statement. Step 1, for n is equal to 1. For n is equal to 1, the statement is P1. LI side of P1 is equal to AI plus BA whole to the power 1 is equal to AI plus BA. Array side of P1 is equal to a to the power 1 I 1 into a to the power 1 minus 1, that is equal to 0 BA is equal to AI plus BA. Now we have LI side of P1 is equal to RI side of P1. So P1 is true. In mathematical induction, the first step must be proved. For n is equal to 1, P1 is the statement which is true. Step 2. for n is equal to k. Let pk is true for some positive integer k. pk so that ai plus ba whole to the power k. Since n is equal to k, a to the power k I plus k a to the power k minus 1 ba. For n is equal to k, pk is this. The second step is assumed that it is true by the principle of mathematical induction. First step must be proved. Second step is assumed to be true. Step 3. For n is equal to k plus 1. Now, to show p k plus 1 is true, whenever pk is true. The third step must be proved with the help of a second step, that is pk. Now, pk plus 1 so that ai plus ba whole to the power k plus 1. The left hand side is ai plus ba whole to the power k plus 1. Is equal to ai plus ba whole to the power k into ai plus ba this can be written as in this form. By step 2, it is assumed that ai plus ba whole to the k is this value, which is equal to a to the power k I a to the power k into I plus k a to the power k minus 1 ba into ai plus ba, which is same as a to the power k I into ai plus ba plus k a to the power k minus 1 ba into ai plus ba. since x plus y into z is equal to xz plus yz, and x y plus z is equal to xy plus xz. Matrix multiplication is distributive over addition. It is a matrix, it is also a matrix. X plus y, it is taken as a z. This into this plus this into this, which is same as a to the power k I into ai plus a to the power k I into ba plus k into a to the power k minus 1 ba into ai plus k into a to the power k minus 1 ba into ba. By the principle of distributive law, matrix multiplication is distributive over addition. It is a matrix, 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 ai is a matrix and ba is a matrix, which is same as a to the power k plus 1 I into I, that is equal to I square. I square is I plus a to the power k into b I a. I a is the same as a. I a is the same as a. A to the power k into b I into a, that is equal to a plus k a to the power k minus 1 into a, that is k into b k a to the power k b ai is equal to a plus k a to the power k minus 1 b square. Since I square is equal to I, and IA is equal to A, which is equal to AI, which is same as a to the power k plus 1 I plus k a to the power k a to the power k b a to the power k b into a to the power k a to the k b a k plus 1 plus 0 matrix a is equal to a square is equal to a into a, which is the same as 0 1 0 0 0 1 0 0, which is equal to 0 0 0 0 is equal to 0 matrix, which is same as a to the k plus 1 into I plus k plus 1. A to the k can be written as k plus 1 minus 1 b a. So p k plus 1 is true. So p k plus 1 is true. N is replaced by n plus 1. N is replaced by k plus 1. The right hand side is also n is replaced by k plus 1. N is replaced by k plus 1. N is also replaced by k plus 1. So p k plus 1 is true. The statement satisfies step 1, step 2 and step 3. Therefore, Pn is true for all n belongs to capital N. Clear? Write down. Question number 9. Find x if product of 3 matrices is equal to 0 matrix. Capital O represent 0 matrix. It is a matrix of order 1 cross 3. It is a matrix of order 3 cross 3. It is a matrix of order 3 cross 1. Which implies this 1 cross 3, 3 cross 3. So the matrix multiplication is defined since number of columns of first matrix is equal to number of rows of second matrix, that is equal to 3. By the matrix multiplication rule, go through row 1 and come down in column 1. Multiply the corresponding elements and add them. X into 1, that is equal to x, minus 5 into 0, minus 1 into 2, minus 2. Next, go through row 1 and come down in column 2. Multiply the corresponding elements and add them, which gives x into 0, that is 0, minus 5 into 2, minus 10, minus 1 into 0, that is 0. Next, go through row 1 and come down in column 3. Multiply the corresponding elements and add them, which gives x into 2, that is 2x, minus 5 into 1, that is minus 5, minus 1 into 3, that is minus 3. 1 cross 3, 3 cross 3, the result will be 1 cross 3. Clear? Into x4 x4 1, 3 cross 1, and it is 1 cross 3 is equal to 0 matrix. 1 cross 3, 3 cross 3, 3 cross 1. It starts from 1 and ends in 1. So the 0 matrix will be order 1, 1 cross 1. 1 cross 3, 3 cross 3, 3 cross 1. It starts from 1 and ends in 1. So it is a 0 matrix of order 1 cross 1. Which implies this. 1 cross 3, 3 cross 1. The matrix multiplication is defined since the number of columns of a first matrix is equal to number of rows of a second matrix, that is equal to 3. X minus 2 into x, that is s square minus 2x. Minus 10 into 4 minus 40. 2x minus 8 plus 2x minus 8. 1 cross 3, 3 cross 3, the result will be 1 cross 1, which is equal to 0 matrix of order 1. Clear? Now two matrices are equal. Two matrices are equal if their corresponding elements are equal. 2x 2x cancel. S square minus 48 is equal to 0 matrix of order 1. Two matrices are equal if their corresponding elements are equal, which implies s square minus 48 is equal to 0, implies x is equal to plus or minus square root of 48, which is same as plus or minus 4 root 3. Therefore, x is equal to plus or minus 4 root 3. Clear? Write down. Question number 11. Find the matrix capital X so that capital X into matrix having elements 1, 2, 3, 4, 5, 6, which is same as matrix having elements minus 7, minus 8, minus 9, 2, 4, 6. It is a matrix of order plus 3. It is also a matrix having order 2 cross 3. It has 2 rows and 3 columns. Implies this. Capital X is the matrix having order 2 cross 2. Since if A is a matrix of order m cross n, B is a matrix having element Bij, n cross r, then AB is defined. Matrix multiplication is defined when the number of column of A is equal to number of row of B. N is equal to N, so the matrix multiplication is defined. AB is equal to capital C is the matrix Cij M cross N, N cross R, the result will be M cross R. The result is 2 cross 3. If X is the matrix with order 2 cross 2, then the left hand side is defined. 2 cross 2, 2 cross 3, the result will be 2 cross 3. So, X is the matrix having order 2 cross 2. Clear? Since the result is 2 cross 3, the order of X must be 2 cross 2. 2 cross 2, 2 cross 3, the result is 2 cross 3. Let capital X having elements A, B, C, D. Equation 1, it is the equation 1. Equation 1 implies this. A, B, C, D, 1, 2, 3, 4, 5, 6 is equal to -7, -8, -9, 2, 4, 6. By the matrix multiplication rule, go through row 1, come down in column 1, multiply the corresponding elements and add them, which implies this: A into 1, that is A, B into 4, that is equal to 4B, next go through row 1 and come down in column 2, which gives 2A, 5B. A into 2, that is 2A, B into 5, that is equal to 5B. Next, go through row 1, come down in column 3, that is 3A plus 6B. 3A, 6B. Go through row 2, come down in column 1, which gives C into 1, C into 1, that is equal to C, 4 into D, that is equal to 4D. Next, 2C plus 5D, 3C plus 60, 3C plus 60. It is a 2 cross 2 matrix, it is a 2 cross 3 matrix, the result will be 2 cross 3, which is a match. Matrix having elements -7, -8, -9, 2, 4 and 6. It is also 2 cross 3. Two matrices are equal if their corresponding elements are equal. Two matrices are equal if their corresponding elements are equal, having same order. It is 2 cross 3, it is also 2 cross 3, implies yes. A plus 4B is equal to -7, (2A) plus 5B is equal to -8, 3A plus 6B, 3A plus 6B is equal to -9, and C plus 4D is equal to 2 2c plus 5d is equal to 4. 3c plus 6d is equal to 6. Two matrices are equal if their corresponding elements are equal. A plus 4b is equal to minus 7, which implies 2a plus 8b is equal to minus 14. 2a plus 5b is equal to, and 2a plus 5b is equal to minus 8. By the subtraction, 3b is equal to minus 6 implies b is equal to minus 2. A is equal to minus 7, a plus 4b is equal to minus 7, a is equal to minus 7 minus 4b is equal to minus 7 plus 8 is equal to 1. AB order pair, A is equal to 1, B is equal to minus 2, satisfies the third equation. A is equal to 1, that is 3, B is equal to minus 2, which is equal to minus 12 plus 3, that is equal to minus 9, satisfies 3a plus 6b is equal to minus 9. Clear? A is equal to 1 and b is equal to minus 2. Next, c plus 4d is equal to 2, which implies 2c plus 8d is equal to 4, and it is given by 2c plus 5d is equal to 4. 2c plus 5d is equal to 4. By the subtraction, 2c cancel. 3d is equal to 0, d is equal to 0. Clear? D is equal to 0. For d is equal to 0, c plus 4d is equal to 2, d is equal to 0, d is equal to 0 implies c is equal to 2. Clear? 2, 0. Cd is equal to 2, 0. Satisfies the third equation or not? C is equal to, d is equal to 0, 3 into 2, that is equal to 6, since d is equal to 0. Satisfies. C plus 6d is equal to 6. A is equal to 1, B is equal to minus 2, C is equal to 2, and D is equal to 0. Now, capital X is equal to a capital X is a matrix having elements A, B, C, D, which is same as A means 1, A is equal to 1, B is equal to -2, C is equal to 2 and D is equal to 0. A is equal to 1, B is equal to -2, C is equal to 2 and D is equal to 0. Find X. It is the answer. Whose order is 2 cross 2. Capital X is a matrix having elements 1, -2, 2, 0 with order 2 cross 2. Clear? Write down. Question number 2. If A is a matrix of order 3 having each element unit, prove that A to the n is a matrix of order 3 having each element 3 to the power n minus 1. N belongs to capital N, n is a natural number. The statement can be proved by the principle of mathematical induction since n belongs to capital N. Mathematical induction is applicable when n belongs to capital N. The statement prove the statement can be proved by using the principle of mathematical induction. The given statement can be proved by the principle of mathematical induction. Let Pn or P the function of n. Let Pn or in this form or in this form be the statement. Be the statement. Pn so that A to the n is equal to 3 to the n minus 1, 3 to the power n minus 1, and 3 to the power n minus 1. Let Pn be the statement. Pn so that A to the n is a matrix of order 3 having each element 3 to the power n minus 1. Where it is given by A is the matrix of order 3 having each element 1. Clear? The statement can be proved by the method of induction. Step 1. In mathematical induction, there exist 3 steps. The first step must be proved The second step is assumed to be true, and the third step will be proved with the help of a second step. For n is equal to 1, P1 for n is equal to 1, LI site, it is the LI site and it is the LI site, it is the RS site. LI site of P1 is equal to A to the power 1, which is equal to A, is equal to 1, 1, 1. Each element is unit, that means 1. Array site of P1, that means 3 to the power 0, 3 to the power 0, 3 to the power 0, which is same as 1, 1, 1. Here LI site of P1 is equal to array site of P1. So P1 is true. So P1 is true. The first step is proved for n is equal to 1, which is true. Step 2. For n is equal to k, let pk is true for some positive integer k. Pk so that a to the k is equal to 3 to the k minus 1, 3 to the k minus 1, 3 to the k minus 1. Each element is 3 to the power k minus 1, 3 to the 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 k minus 1. Let pk is true for some positive integer k. Pk so that a to the k is equal to a to the k, which is a matrix of order 3 having each element 3 to the power k minus 1. For n is equal to k, it is a to the k and each element of this matrix is also 3 to the power k minus 1. Step 3. For n is equal to k plus 1. To show p k plus 1 is true whenever pk is true. Now p k plus 1 so that a to the power k plus 1. The left hand side is a to the k plus 1. K plus 1 is replaced by n. If k plus 1 is replaced by n in each element of the right hand side, then p k plus 1 is true. The left hand side, n is replaced by k plus 1. The right hand side must be replaced by k plus 1 in the place of n, so that p k plus 1 is true. Now p k plus 1, which is same as a to the k into a to the k is assumed that the statement is true. Pk is true for n is equal to k. A to the k is equal to this, which is same as 3 to the power k plus 1, 3 to the power k plus 1, sorry, k minus 1. K minus 1, 3 to the power k minus 1, 3 to the power k minus. A is given by 1, 1, 1, 1, 1, 1. Each element is a unit. By the matrix multiplication rule, A is given by this, which is same as, by the matrix multiplication rule, go through row 1, come down in column 1, multiply the corresponding elements and add them. This into 1, this into 1, this into 1, which gives 3 times of 3 to the k minus 1. Go through row 1, come down in column 1, multiply the corresponding elements and add them, which gives 3 into 3 to the power k minus 1. Similarly, each element is equal to 3 into 3 to the power k minus 1. 3 into 3 to the k minus 1. 3 into 3 to the power k minus 1. Which is same as 3 to the k plus 1 minus 1. K minus 1 plus 1. 3 to the power k minus plus 1 minus 1. 3 to the power k plus 1 minus 1. 3 to the power k plus 1 minus 1. 3 to the power k plus 1 minus 1. 3 to the power k plus 1 minus 1. 3 to the power k plus 1 minus 1. 3 to the power k plus 1 minus 1. 3 to the power k plus 1 minus 1. Clear? When n is replaced by k plus 1 in the left side, the right hand side, in right hand side, k plus 1 is replaced by n. N is replaced by k plus 1, n is replaced by k plus 1, n is replaced by k plus 1. So p k plus 1 is true. So p k plus 1 is true. Whenever Pk is true. That is K is true implies K plus 1 is true. If K is equal to 1, is true implies so Pk plus 1 whenever Pk is true. K is P1 is true implies P1 is true implies P2 is true. That implies P2 is true, that implies P3 is true. P3 is true implies P4 is true. That is P n minus 1 is true, that implies Pn is true. Therefore, Pn is true for all n belongs to capital N, where capital N is the set of natural numbers. Hence, the statement is proved that true. Hence, the statement is proved that true. The given statement is true for every natural number. Clear? Write down. Question number 13. If capital A is a square matrix of order 2 having elements alpha, beta, gamma, minus alpha is so that A square is equal to I, then which one is correct? Given A square is equal to I means unit matrix. Since A is a matrix of order 2, A square must be a square matrix of order 2, which is same as I2. I2 means unit matrix having order 2, implies alpha, beta, gamma, minus alpha. Alpha, beta, gamma, minus alpha. I2 means it is a unit matrix of order 2. By the matrix multiplication rule, it gives alpha square plus beta gamma alpha beta minus alpha beta. Alpha gamma minus alpha gamma, alpha gamma beta gamma beta minus alpha square, minus 1 plus alpha square. Clear? Alpha square plus beta gamma. Alpha beta minus alpha beta, gamma alpha minus gamma alpha, gamma beta plus alpha square, which is equal to 1001. two matrices are equal if their corresponding elements are equal, which implies this alpha square plus beta gamma is equal to 1, which implies this 1 minus alpha square minus beta gamma is equal to 0. It is 0 matrix, it is 0 matrix, it is the alpha plus which is same as alpha square plus beta gamma, it is 0. It is also 0 gamma beta plus alpha square is equal to 1001. This is same as 1. Alpha square plus beta gamma is equal to 1. 1 minus alpha square minus beta gamma is equal to 0. And gamma beta plus alpha square is also 1. The correct option 1 minus alpha square minus beta gamma, that is C. It is the correct option. Next, question number 15. If A is a square matrix so that A square is equal to A, then I plus A whole cube minus 7A is equal to dash. I plus A whole cube minus 7A. A plus B whole cube. That means it can be obtained by the matrix multiplication, which gives I cube plus 3 I square A plus 3 I A square A cube minus 7A, which is same as I plus 3IA plus 3 A square is equal to 3IA plus A cube can be written as A square into A minus 7A I to the power n is equal to I. N belongs to capital N. I square is equal to I, which is same as IQ. IQ is equal to I square is equal to I, which is same as I plus 3A plus 3A plus A square is equal to A into A minus 7A, which is same as I. Since I into A is equal to A into I is equal to A. Clear? Clear? I into A, which is same as AI, which is same as A. 3A plus 3A, that is equal to 6A. A into A, that is equal to A square. A square is equal to A minus 7A, which is same as I plus 7A minus 7A, which gives value I. I the unit matrix of order 2. So the correct option is C. It is the answer. Clear? Okay. Write down